All right, so I can help myself from, right, I can help myself from just going away tonight without completing this. So I'm gonna basically just finish out this session, right? You could always play it back and watch it at your own convenient time. But I want to finish out at least up to multiplication tonight. Right? There's anyway I'm gonna feel like I accomplished something. So offer information and guidance. Right? Offer information and guidance. Alright, so it's given you a few minutes to join. Right, just a few minutes to join. I think I sort out the issues with my pen and so on, and getting my whiteboard to show up, and hopefully we have a better flow going forward. Right, so that's about it. So let's see. Let's hear from folks if there's anybody else who's gonna join the live, and we could go from there. All right, we could go from there. And as it gets a little later, also the internet tends to work a little better. It works a little better, so hopefully we have a better smooth flow. All right, let's go. So on the last slide we were looking at this, we established in our previous slide that matrices basically, if you have to add them, they must be of the same order, and we add or subtract corresponding elements. So with that with knowledge, we could solve these type of questions. Like for example, you have a 2 by 2 matrix here, subtracting another 2 by 2 matrix, which give us or equals to a 2 by 2 matrix. But notice that there are some unknowns. You want to know what is A, what is B, what is C. So when you see a question like this, you could start seeing right away, this can be solved like an equation. So we have, for example, we have A minus 4, because they are corresponding elements, it will give a corresponding element answer, which is equal to 5. And therefore, making A the subject, we have 5 plus 4. Therefore, A is equal to 9. And that's our solution for it. A and B, A looking the same, but group is a 9 anyhow. And we work on that. So that's simple. Let's see, what is the answer for C? So notice we have 3 minus C is equal to 0. So likewise, making C the subject of the formula, carrying over, let's see, 3 go over, it becomes 0 plus 3. Plus 3. So minus C is equal to 3. And therefore C oh, this is moving out my tablet already. Starting to scroll up. So therefore C. I'll limit on this thing and I'll learn. Oh, another little issue I encountered here. Tablet giving me a limit of how far I could scroll. So it's like I'm gonna keep in focus. Interesting. It's like the learning center. So I go. So therefore C is equal to minus 3. Right? Simply multiply both sides by negative, so make it positive. So C is equal to minus 3. Let's look at, I think you want to see why did we skip B? So we have B minus 5. This is equal to 5. And so therefore we have, this is the same as b. Negative and negative is plus 5 is equal to 5. Therefore, making b the subject, we have b is equal to 5 minus 5. And therefore, this gives us b is equal to 0. Easy as that. And then we have to find for d. So we have to find for d. Let's go. We have minus 1 minus d is equal to 0. Therefore, carrying minus 1 over the equal sign, we have minus d is equal to 0 plus 1. So minus d is equal to 1. And therefore, making d the subject multiplied by minus 1 both sides, we end up with d is equal to minus 1. And that's our answer. Alright, so that's basically it. Alright, we found the values for A, B, C, and D. Good. Next concept. So let's begin this. So quick questions, so spark some interest. What is the dimension of each of the following matrices? When they ask you dimensions, you got to look at the number of rows times the number of columns. Right? And that's an easy concept, I should believe. So let's go. So this here, we have 2 rows. Right? 2 rows. We have how many columns? C1, C2. So we have R1 and R2. So therefore, we have a 2 by 2 matrix. How many rows? R1, R2, R3. How many columns? C. 1 column. So this is 3 by 1. I think you got the drift by then. That's because I could skip a few more with this one. This is 1 row. But how many columns we have? We have 2 columns. So there's a 1 by 2 matrix. And you could figure out the rest quickly for yourself. For the matrices A, B, C, fine, and they give you the questions. What is A plus B? In other words, what is matrix A plus matrix B? So therefore, you set this down nice. You have 3, 1, 2, 0, plus 2, minus 1, 0, minus 4. So that's matrix A there and matrix B. And then you could work out your solutions quickly. It's showing up on screen. I shall check for that. I'm sorry. I do apologize. I do apologize. I hope you were able to see that here. Right. Let me submit one little thing. All right, so we want to know, they gave us 3 matrices, and they basically want us to know what is the addition of A plus B and A minus B and so on. So I just set it down, and remember the rule. Simply corresponding element with corresponding element. What did I just do? Corresponding element with corresponding element. So I said I need to just get this over with, you know, so we can move on to something new and fresh. At the same time, it's an opportunity to learn. And I just want to learn, you know, some of the kind of challenges that we may encounter while working online. And I basically want to see how quick and easy I could navigate those you know, those setbacks or hiccups. So that's why I'm just being persistent. I'm also teaching you something too, that, you know, you must never be too quick to give up. You know, when you have good things to do, they don't always come by easy. There's always things that we want to, just throw you off your goal, your mission, right? And those technical difficulties, they happen. Somebody, I cannot allow that to throw me off, because it's very important that I, spend this time with you and give you an opportunity to, feel the kind of confidence and relaxation that you may need at this time. I'll give you that support, right? So that's why I'm still steaming ahead. So we're looking at addition. We just run a few examples, right? So we have a few sums. So I could take it. I hope you can all see on the screen. I'll zoom out a little bit more. That's it. I think next time I need to bring my monitor screen a little closer. But this is just how I set up. I don't have, gotta find something to sit on to keep it close by, so I don't have to be looking sideways away from the camera while I adjust. All right, so let's go. So therefore I set up A plus B. So let's go through and do the setup. So you have to show your working. So we have 3 plus 2 because they are corresponding elements. White space, don't put a plus sign and equal in between, and some people like to do that. Then we have 1 plus minus 1. Then we go 2 plus 0. And then we have 0 plus minus 4. Simplifying, what do we get? 3 plus 2 is 6. Positive 1 plus negative 1 is the same as 1 minus 1, which gives us 0. We have 2 plus 0 is 2. We have positive and a negative, the same as negative, so 0 minus 4 gives us minus 4. And that's our solution. That's all we have. Must be able to, if I remove this and then, anyhow, the range, I see the range. What's the range of my motion? Alright, I think I know what's the problem. Good. So that's it. Let's try one is a little long and complex ones, it seems. So we have 7, 0, 0, space there, 0, 5. And let's scroll up a little so I can be comfortable. So let's go. Then you have minus A, which is 3. And you notice here, anytime you have, don't put the comma between, just white space, 3, 1, 2, 0. And as I said, anytime you have these here, always ensure that you start from your left hand when you're doing these sums. Right? You have addition and subtraction going on. And then we have B, which is 2 minus 1, 0. And we have minus 4. How you all go there? So that's it there in a nutshell. How do you simplify that quickly? What's your mind telling you to do? Talk to me. Now, what some people tend to do sometimes, they work the first pair first, right? But we could string them because all the corresponding elements. So we could go 7 minus 3 Oh, not a space, man. Look on a new line. So we have 7 minus 3 minus 2 in the white space, 0 minus 1 minus 1. We have, go down to the second row, 0 minus 2 minus 0. There we go. Second column, second row, 5 minus 0 minus 4. And more range of movements disappearing. That's good. I think my problem is how I set that up. Center myself. Okay. That's how we do our positioning on mouse. I ran out of space already. That's what happened based on my tablet, and I guess I gotta learn how to operate this thing. Let's hurry up here. I hope you're simplifying for me by time. Oh, good. So let's go. Put the big brackets. Let's simplify. So if you have 7 things, you take away 3. That's how much you leave with. That's 4. And 4 take away 2. Gives us what? 2. You have 0 things, and you take away 1. You end up with minus 1. Then you have a negative and a negative, that's positive. So minus 1 plus 1 is 0. And you have 0 things, and you take away 2. You end up with minus 2. Minus 2 take away 0 is minus 2. Then we have 5. Take away 0 from it, still 5. Then you take away 1. You're going to end up with 4. And that there is the solution. Right, so that's simple addition. Good. So that being said, let's move on and let's try a little bit of multiplication. Multiplication. So we look at first scalar multiplication quickly. So you have a matrix and it's been multiplied by some number outside. How do you really treat it? That's a real question. How do you really treat it? And then you go and see, for example, there are 2 types of multiplication you find for matrices. We look at scalar multiplication. And here is how it goes. Here, each element of the matrix is multiplied by a scalar number. For example, you have 2 outside and you have a matrix. It means every element in the matrix must be multiplied by the scalar quantity outside. It doesn't matter if it's a fraction, it doesn't matter what's out here. Whatever it's out there, every element must be multiplied by that. So we have 2 times 4, 2 times 3, 2 times 1, 2 times minus 1, which gives us respectively 8, 6, 2, and minus 2. Please pay attention, alright, that there's no equal sign in between, it's just white space. You always try to maintain your rows and column arrangement. And that is simple. So let's look at this work. Let's look at this work example here, people. So, well, we gotta work it. So look at these are 2 matrices. We have A and B, and they give you the question, what is 2A? So 2A means 2 times the matrix A. So let's set that up quickly and get going. So for example, so that is 2 times minus 5 to 6 and 0. And so we have 2 times minus 5, white space, 2 times 2, come down to the next row, 2 times 6, white space, 2 times 0. This gives us 2 times minus 5 is negative 10. 2 times 2 is 4. 2 times 6 is 12. And 2 times 0 is 0. And that's our solution. Right? That's matrix multiplication. Every element in the matrix multiplied by the scalar quantity outside. Let's do half times 2. That seems to be a nice one to work on. Trying to scroll and stay within the confines. So let's go. So we're gonna have a half times a, which is minus 5 to 6, 0. This equals a half times minus 5, white space, a half times 2. Then you go down to the second row, a half times 6, white space, a half times 0. This gives us, let's simplify again. Let's go. So that's gonna work. What do we have? We have here half times 5 is 5 over 2, or 2 and 1 remainder, so 2.5. 2 into 2, that gives us 1. 2 into 6 is 3. So we end up with 3 and 0. And that's our solution. 2.5, 1, 3, 0. That's simply it. That's what you call scalar multiplication. So, I mean, this is just the easy stuff. The rest is easy, but you got to focus a little bit more. So I know it's late, but again, it's live. You could watch it back at any time. So maybe let me see if I could push it a little and look at the last type of multiplication. And you can always watch back this video at a convenient time when you're resting or something. Right, so 3 plus 2 is 5. So I'm now checking the comments. See the few comments. Did I miss something? All right. Okay. All right. Correct is right. You have to multiply everything in the bracket by the number outside, whether it's going to be a fraction, whether it's going to be a decimal, whether it's going to be whatever number it's outside. You got to multiply every element, right? That's scalar multiplication. All right, so let's take a deep dive now into matrix multiplication. All right, let's take a deep dive into matrix multiplication. Now this is a nice one. I'm gonna run this one a little slower for the sake of clarity. Yeah, if you have any questions, feel free to ask and post. All right, feel free to ask and post and stuff. So I have some explanation notes here. I'm gonna try to display on screen. I hope you've seen it. I'm gonna make it as big as I could make it. Oh, but I think I overdo it there, but there you go. All right, so this is matrix multiplication. All right, so this now is a very important concept. I advise that you yarn it out because I know it's almost 10 o'clock if you're watching live. But if you're fresh in the morning and you're watching this, you should be able to grasp these concepts a little better. Let me just make sure I am able to see what is being displayed. All right. All right. Let me start this now. Couple things to know, students. You can multiply two matrices under a certain condition. And the condition is very important for you to take note. Let's say you have a matrix. Let's look at this example down below. Practice. Good. Let's look at this example down below. Notice you have a matrix here. You know this is a 2 by 2 matrix, and this one here is a 2 by 1. All agree? Seeing that? No. You can only multiply two matrices if the number of rows in one matrix, so we have R1, R2, I think I seen it wrong. Let me just correct myself again, but then I catch myself before I go further. You can only multiply two matrices if the first matrix, the number of columns, which is C1, C2, how many columns do we have? We have 2, is equivalent to the number of rows in the second matrix. That is the most important point to note. In other words, I cannot multiply, let's say, another matrix C, and it was like 2, 1. I cannot multiply A times C. Why? Because the number of columns in this case, 1, 2 in A, is greater than the number of rows that exist in C. It's only one row. So I cannot multiply those two matrices. But I could multiply matrix A and B because why? It has the same number of rows as columns as A. Are you getting that concept? You can only multiply two matrices if the number of columns is equal to the number of rows in the second matrix. Let us sink in. You can only multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So, once you have that concept in your head, then we get on to the little technical part. Let's multiply matrix A and matrix B in this example. So, let's look at it quickly here. How do we actually go about doing this? Now, how you go about doing this is that you do row. Let me show you. You multiply row by column. So let's go through this here first now. So we go, ready? We have 1 times column minus 1. Now notice carefully, we say plus next column minus 1 times second element times 2. So what we did row 1 of the first matrix by column 1 of the second matrix. And between each element, we put an addition sign. Then we go to the next one, which is row 2 by the same column 1 again. So we have minus 2 times first element, which is minus 1. Right, minus 1. Put these signs here in brackets. You know, that's for the sake of simplicity. Then we go plus 3 times the second element in the column 1, which is 2. We put everybody in brackets. So let me go that again for the benefit of everybody so that we ensure that we are on the same page. And you get the eraser. Look at these things here so you can see it clearly. To multiply two matrices, we go row by column. Row by column. Go again. R1 by column 1. Are we good there? Then we go to row 2 by column 1 again. Simple. That's in this case. Let's try it again. And remember, we could multiply these two matrices because this has the same number of columns as B has rows. Or B have rows, sorry. Right? That's why we could multiply them. So, quickly, let's speed up this here quickly. So, let's simplify. 1 times minus 1 plus minus 1 times 2. First row, column finish. Let's go to the next row. Minus 2 times minus 1. And then we get plus 3 times 2. Second row, complete with the column that is available. Simplifying, what do we get? Let's simplify. We have what? 1 times minus 1 is minus 1 plus minus 1 times 2 is minus 2. Right, put the bracket around. Minus 2 times minus 1 is positive 2. And 3 times 2 is 6. Simplifying, what do we get? Minus 1 plus minus 2, correct, is right? So this positive and negative gives you a negative, so it is minus 1 minus 2, which will give us minus 3. And I have 2 plus 6, which is 8. See that? And that's it. Any questions there? Let me check. Somebody asked a question. Well, I want to look for the feedback. Does this topic always come in CSEC, sir? Ha! Yes, it does. Always do. They come in a different form because it's named. Later on, we're going to see how to solve simultaneous equations using matrices method. We're going to learn how to find the inverse of a matrix and all these different little things.